Good afternoon, everyone. Let's discuss for the next 25 minutes about API and databases. I'm Cedrick Lunven. I'm a developer advocate at DataStax during Days, and I created an open source framework 5 years ago to do some feature toggle at night. Previously today we talked about FF4J. Now let's go back to database and the day work. So here are my coordinates. During these 25 minutes, I have 3 objectives for you. First, and probably the most important, is provide you a working API implementing REST, Grpc, and GraphQL, just for you to copy-paste, because this is what we all do, copy-paste, and then you get your hands and get what happened. I will give some implementation details through demo, hopefully half of the presentations, and reveal my feedback and how to pick one of the others among those 3. So at DataStax, the Evangelist Advocates team create a lot of contents around Apache Cassandra, because DataStax provide an enterprise version of Apache Cassandra. So we provide blog posts, training, podcast, and reference applications. And Killer Video, available at dev.killervideo.com, is one of the reference applications. It's available in 3 languages, Java, Node, and C#. And we try to explain and demonstrate how to build a microservice application on top of Apache Cassandra. Which is interesting with Apache Cassandra is you cannot do you have to be very prepared to do your data model. You have to have proper methodology. You can do whatever you want. Just create some beans and expect that the tables will be created automatically. You really have to know 2 things. First, the entities and relationships, and the application workflow. This is your queries. And from those, you can start to define your tables, logical, physical, and just ending with the script. So I want to run into those steps, because when you want to create an API, you may go and to the same, very same steps actually. So first, conceptual data model. In Killer Video, you can create some comments on video. So you will have comments per video and comments per user, because when you have 2 pages when you display the comments. First page is comments on a video, of course. Second is comments for your user, and you will have to create those comments. So this is just the MCD. Same for the queries. 2 screens, 2 types of queries, and of course the CRUD operations. So far, so good. Then we go to the logical data model, and because it's Cassandra and because you have to be very aware of the query you have to make, well, even if you are working with a single comment, you will have 2 tables to create and 2 tables to fill each time. Because with Apache Cassandra, for each query, you will create a dedicated table, just for be able to perform well. So those 2 tables are there. K means partition key, C is for clustering column. Never mind, just an Apache Cassandra concept. Let's move on to the physical data model, where you will define exactly which kind of attribute you will use in your table, and ending with this DDL schema. So 2 tables. And okay, I will work with the comment concept. And when I need to access my database, again, from my MCD, conceptual data model, well, I will find all the entities, relationship, and mutation, the CRUD operations. And with everything related to application workflow, your queries, it's another world. And depending on the API implementation you choose, one will be fit best for the MCD and the other for the application workflow. Of course, you can implement everything with all the technologies, but some behave best than others. So if you look at the MCD, some criteria you would like to use, CRUD operations, okay? What about atomicity? Now I need to insert the same data in two tables. What about sync versus async? And in the API, how can you do that? Consistent level, okay, it's transaction, no problem. But yeah, in Cassandra, you don't have the transactions. And on the query function part, extra capabilities to look in. What about paging, sorting, filtering, and caching on each of those kind of queries? And latest, but not least, all the versioning, performance, and latencies about the kind of access you can do over your database. So in those tools in action, I would like to explain how we created first the data object access, the DAO, and then how reusing that DAO, we implement the API in REST, Grpc, and GraphQL. Okay. Okay, so no cheating. We do have the data model we just created. I drop my database and just recreate the database with the tables we just defined together. So if I go to SQL and find my killer videos, keyspace, which is a database for Apache Cassandra, here I find my two tables. Okay, so far so good. So first things first, let's look at the DAO, data access object. So on Eclipse here, I have a multi-module Maven project. And as you can see, as you saw in the slides, here is the killer video.dsc. Not a lot of dependencies to comment, but of course I will use the driver. I will use some validation API, and some things to do some unit test. Spring Data, what about Spring Data? What about ORM? What about GPA? Okay, in 90% of the use case, you will think first by Spring Data, create your beans, CRUD repository, and you're good to go. And it's fine, I love Spring. But here, look at that. You have two tables for the very same object. So what do you want to do? Create multiple CRUD repositories? Put that in a single transactions? On my use case, I choose to not use Spring Data, not of that problem, but others maybe a bit more hidden, like the way Spring Data behaved against Cassandra, but never mind. So in that comment DSC DAO, I will define create, read, update, delete method, insert using batch statement, and look at that. I define two methods. The first is using synchronous, execute, and the other asynchronous, because more and more API will be asynchronous. So far, REST used to be full synchronous, and the implementation I give you here is synchronous, using one of the ways to implement REST, GAX, RS, or using Spring MVC for this one. Here you find a search returning a result list, okay? And in the query, you will find not only the video ID to give me all the commands for my video, but also some kind of start just to not retrieve all the database. Again, find all in the Spring Data world with Cassandra, it's not a good idea. You will retrieve all the lines from your tables and just blow up both your cluster or your client application with too much data. Okay, here's the updates. Okay, so here it is. So we have all the four methods, create, read, update, deletes. Actually, create or update is the same. It's upsert for Apache Cassandra. And the query, which is find by and using some sorting and paging stuff. If I need to create a REST API, it's pretty easy. I won't dig too much into the details because you are pretty used to it, I guess. We all are. Let's say we will create some resources. The command resources to implement put and delete. So let me, and when you dig into the queries and function, then you have to say, okay, which kind of resource I need to create to implement those queries, those functions, because it's not out of the box. You have to think which is the best way to put the resource in the correct order just to make it available. So my REST API is the Spring Boot 2 applications, leveraging on OpenAPI Swagger to expose the endpoint, using Spring MVC to expose the resources, and nothing really complex to say, just for you to have a reference standpoint, the REST API to work with commands. So if I go to the DSC and create a bunch of commands using not yet the API, but let's say just the DSC, just the DAO, suspense. Okay, so here I got my user ID, and I created a bunch of commands for that user ID. And if I go to here and put my user ID, I just found I created a bunch of commands for this user, but I also have the very same comment in the other tables. So if I go to by video, it's also created in the other tables. So from that, I can, of course, use the REST API, one of the endpoints, just to list the command for a user, ask for this user ID. Let's say try it out. I would use that user ID and execute and find my super comment here. And I could do the same using, but nothing special. Just reference point, you have your REST API using Spring Boot. It's cool, it's working very well for synchronous call. For asynchronous call, now using Spring Framework 5 and Spring Web Flux, you can create some async REST API using HTTP2. But no demo for that one yet. Instead, for everything related to async, I will illustrate through gRPC, provided by Google, remote process call. So now let's go to the gRPC implementation. Again, it's a Spring Boot applications. First things to do when you deal with gRPC is to create the interface, which is a proto. It's a proto file. Come on. Oh no, no. It does not want to open my proto file. Okay, so in the proto file, you will define the services with the functions, and this is a part where REST is not very good at, just defining services and operation, and the gRPC is here to help. So I define the methods, functions. I also define the bin in the interface, the request, the response for each of my functions, and then using Maven profile, Maven plugin, I can show you here. I will generate the bin expected by gRPC. Bin will be defined. The serialization format is protobuf, and so I need to generate all that bin, leveraging on the proto format to generate those bins. And okay, now if I package, I will find here my bins created to me, both the services and the bin, and I'm able to just create services, extending the services generated by gRPC. And I need to create the method here, the full method, reusing the object. And this is a key part here. Instead of just returning the object, I will return a stream observer of the object, and only when the response comes back, I will put that in the stream and get an asynchronous response. And you will see in the client part, you can interact gRPC using synchronous or asynchronous, depending on just the way you implement the client. You can stop and get the response, or just provide you a callback when the response came. So here just validation, and you can find here I can use the async DAO and returning incompletable features, and only put the response in the observer when the response is there. But I can also do exactly the same using the synchronous DAO. And now I will just say on next, okay, empty response. I just created some things. But same things for retrieving the command for video. Here I will find all the commands using the DAO, map everything mapped to the gRPC bin, expecting here, and put that in the observer. Or I can do exactly the same in a synchronous way, expecting and waiting for the result. Okay. When you put a gRPC server in a Spring Boot 2 application, even now, you still have to create your own bin, which is just the gRPC server. The Spring Boot starter gRPC is there, but it's not really for the latest version of gRPC, 1.10. It's just a few versions behind, so still need to create the server here. So here you see start the service, run as Spring Boot app. So for the gRPC, nothing to show in the web UI, but as I said just before, I can use a unit test connecting to the working and just putting the correct user UID. We just find here just to get back my result. And just, okay, just a way to okay, and just getting back my two comments I needed. Last but not least, let's look at the GraphQL implementations again. Spring Boot 2 applications. This time I will implement or add the dependencies for Spring. Okay, Spring. No. If I don't open the correct one. Okay, so here it is. I will import the GraphQL Java dependencies, the GraphQL Spring Boot starter, and the GraphQL Spring Boot starter, GraphQL, which is a UI generating for you on top of GraphQL contract. So again, GraphQL, back to the contract. To work with GraphQL, I need to define, okay, it doesn't like that. Okay, I need to define a schema. And on top of the schema, you will define, again, queries and mutations. And this is what I like about GraphQL, is, especially with Apache Cassandra, you won't allow any kind of queries. You will just define explicitly which are the queries that are allowed, and the mutation just to update the entities. So you need to define bins as gRPC, inbound, outbound, result, inbound. Define your queries like that with optional parameter of mandatory parameters, and the mutations. And then, because it's Spring Boot 2, expect you to extend the GraphQL mutation resolver and the GraphQL query resolver. So let's here just implement the method just defined in the contract, in the schema. and create inbound, use the DIO, and get back. It's all about mapping. And then I can run that application as well. And so can you. And if I go and see in the GraphQL EHM, I can here find which are the queries that are allowed. So get command video, get user video, and the mutations that are allowed. Here is a create. And I like to constrain my user to use exactly the method I created for him. He can browse, discover by itself which are the methods available in my API, but it cannot create a fancy query that will try to look at 20 tables on the server side and do 10 queries where there are only one once. And okay, I can go to and execute and get back. And the neat part of GraphQL is actually the completions, and you will select which one of the fields you want to get back. Okay, so I implement the 3. And if I have to do some feedbacks, especially for Apache Cassandra, I would say that REST based on resource decouple client or server. You all know that. This is why we like it so much. You can make the API evolve using versioning pretty easily, and it reuse the HTTP verbs. But you cannot pick the fields you want. You have to get everything back from the server, so it can have big payloads. It's pretty, it's not that easy, or it's not that neat to export the functions. You can do that by creating post method or dedicated resources, dedicated URL. You can do, even if it's not the best fit. And by default, you don't have the way to discover which kind of API it is. And this is one of the reasons why I would pick REST, and this is already what we do, and Gipster framework is exactly what it's doing. It generates some REST API to perform some CRUD operation. Still the best way to do it. For gRPC, the neat part is all about asynchronous. So if you have a very large network of microservices, then don't have to wait. The final client don't have to wait each of the intermediate calls just to get the answer. You don't stuck your architecture. It's smooth. You can get the result when it's available. It's based on protobuf, so low latency serialized format. So it's all based on performance, and probably one of the reasons it's so used in at Google. And all the async allows to do all the streamings. But like with protobuf, you still have the file .proto, and you have to give that file to all of your customer clients using. It was nice for the DataStax team because we had to implement the same API in C#, Java, and Node. So starting by gRPC, everything was generated for us, and pretty great to interoperability. But still, it's not the best fit for CRUD operations. It's best fit for API oriented on action. Slack using gRPC to do some action, because it's all about functions and query, not about modify the entities. And last but not least, the GraphQL is a bit in the middle. It's still strongly typed because you still have to provide a schema, which is great. I think that we need to have the typed schema still, just for the client to be able to discover what happened here. You still have the relation, and due to the fact that you can pick the fields you want, you have a lower need for bandwidth, and just you pick exactly the field you need. But still, do you see, just for create 2 methods, I have to create 10 objects just the query resolver, all the beans, all the mutation resolver. So for Java, it's not that simple yet. Caching is not that easy because things is evolving. Versioning as well. As you can see, there is a single endpoint for GraphQL in an application. So each time you add new resource, it must be backward compatible, or you can break compatibility. It's not as easy to have two parallel, GraphQL API with different versions running in the same runtime. And so those technology is mostly used for where latency matters, like the mobile applications, service aggregations on top of smaller services. And it's maybe nice for clients, but it's pretty heavy on server if you don't be careful about what you are doing. And if I go back to my small draw here, just my feedback, I will say that REST fit the best for this part, gRPC for this part, and GraphQL is in the middle. But still, you can implement all the use case with all the technology. Just be careful. At least I provide you a working sample with the 3 technologies, and you can pick the one best fit your use cases. Thank you.